Hello everyone, welcome back to a new session. Today we are going to solve a couple of numericals related to kinetic energy and momentum of exercise 2B of your Concise Physics textbook grade 10. So without any delay, let us go to the video. Let us start with question number 11. Read the question thoroughly given on the screen. If the speed of a car is halved, how does its kinetic energy change? So what do you have to find out here? When the speed of the car is halved, we have to find out the kinetic energy. So the kinetic energy K is given by the formula half mv squared. All of you know it. So for a constant mass, I can write kinetic energy is directly proportional to square of the velocity here. So we have to find out when the V is halved, we have to find out what is the kinetic energy. So initial kinetic energy, I write Ki as half mv square. This is the initial kinetic energy of the body. So what is the final kinetic energy? When V is halved, I can write 1 by 2 m into V becomes half V here. Okay. So I substitute half V over here, half V the whole square. So the final kinetic energy is equal to 1 by 2 m into 1 by 4 V the whole square. Clear? So that's equal to, I can write, just rearrange it, 1 by 4 into half mv square. Clear? So what is half mv square is equal to final kinetic energy, initial kinetic energy. So I can write final kinetic energy is equal to 1/4 of initial kinetic energy Ki. So therefore I can write the kinetic energy becomes 1/4. All right. So I can write the kinetic energy becomes 1/4 of the initial kinetic energy. Clear? Steps are clear to you? Okay. Now let's solve question number 12. Calculate the decrease in kinetic energy of a moving body if its velocity reduces to half of its initial value. So the kinetic energy is given by the formula Ke is equal to half mv square. So for our convenience, let the initial kinetic energy Ki is equal to half mv square. Let it be 1 for our convenience. And the final kinetic energy Kf is equal to half mv. In place of v, we have to, when v is equal to v by 2, v is reduced to half of initial velocity. Therefore I can write v by 2 the whole square. So final kinetic energy becomes 1 by 2 into m into v square by 4. This I can write it as final kinetic energy is equal to, I can take 1 by 4 outside. So I can write 1 by 2 mv square. So what is 1 by 2 mv square? That is equal to 1 by 4th of initial kinetic energy. That's equal to Kf is equal to, I can write 1 by 4th of initial kinetic energy is 1 by 4 into 1, that is 1/4. Clear? So the final kinetic energy is 1/4 of the initial kinetic energy. Here what you have to find out, you have to calculate the decrease in the kinetic energy. So I can write decrease in the kinetic energy is equal to the initial kinetic energy, difference between initial kinetic energy and final kinetic energy. That is 1 minus 1 by 4. That's equal to 4 by 1 by 4. That's equal to 3 by 4. So I can write the decrease in kinetic energy is 3/4 of initial value. 3/4 of initial value. So this is the decrement in kinetic energy when the velocity is reduced to half of initial value. Clear? Okay. Moving on to question number 13. Two bodies of equal masses are moving with uniform velocities v and 2v. Find the ratio of their kinetic energy. So the kinetic energy is given by the formula K is equal to half mv square. Look at this expression. Here 1 by 2 is a constant, mass is a constant. So I can write, since mass is constant, I can write K directly proportional to square of the velocity. Kinetic energy directly proportional to square of the velocity. Clear? So velocity of the body 1, velocity of first body is equal to how much? V. V1 is equal to V. Velocity of second body V2 is equal to, we can take it as 2V. Clear? And since mass is constant, K directly proportional to V square. Hence, what is the ratio of the kinetic energy of the body 1 to body 2? I can write ratio of kinetic energy of body 1 to body 2, K1 by K2 is equal to V1 square divided by V2 square. Clear? So that's equal to, what is V1? V square divided by 2V the whole square. So we are getting it as V square divided by 4V square. V square cancels, and we are getting the ratio of kinetic energy of the body 1 to body 2, K1 ratio K2. We are getting it as 1:4. Clear? So when the velocity is doubled, the ratio between kinetic energy of the body 1 and body 2 comes out to be 1:4. Clear? Okay. Now moving on to question number 14. A car is running at a speed of 15 km per hour while another similar car is moving at a speed of 45 km per hour. Find the ratio of their kinetic energy. We have to find out the ratio of their kinetic energy. Velocity of the first car. Velocity of first car is given as 15 km per hour. And the velocity of second car is how much? Is 45 km per hour. Clear? Yes. We have to calculate the kinetic energy. So the kinetic energy is given by half mv square. All of you know the formula. So 1/2 is a constant, mass is a constant. Therefore, since mass is constant, I can write kinetic energy is directly proportional to square of the velocity. Clear? So here we have to find out the ratio of their kinetic energy. Therefore, ratio of the kinetic energy K1 by K2. Ratio of kinetic energy of the car 1 to ratio to the kinetic energy of the car 2 is given by directly V1 square divided by V2 square. So that's given as V1 square. V1, it is 15. Let it as take it as V1. This is V2. Clear? So V1 15 square divided by 45 square. So that's equal to 15 into 15 divided by 45 into 45. 3. So we are getting the kinetic energy, the ratio of kinetic energy of the car K1 ratio K2 as that's equal to 1:9. So we are getting it as 1:9. Clear? So the kinetic energy of the car 1 and car 2 are in the ratio of 1:9. Clear? Okay. Moving on to question number 15. A ball of mass 0.5 kg slows down from a speed of 5 meter per second to that of 3 meter per second. Calculate the change in kinetic energy of the ball. So here the velocity of the body decreases from 5 meter per second to 3 meter per second. So let us write the data given there. Mass of the ball is given as 0.5 kilogram. Clear? Initial velocity Vi is given as 5 meter per second. So what is the initial kinetic energy of the ball? Ki is half mv square. So place the values in the formula. 1/2 into 0.5 into v square. It is 5 into 5. Solve it and see. We are getting the answer it as 6.25 joule. This is the initial kinetic energy of the ball. Now Final velocity of the ball, velocity decreases to 3 meter per second. Vf, final velocity. Therefore, the final kinetic energy Kf is equal to 1 by 2 m v square. That's equal to 1 by 2 into mass is constant there, 0.5 into 3 into 3. So we are getting the value of final kinetic energy as, solve it and see, we are getting it as 2.25 joule. Clear? So therefore the change in kinetic energy of the ball is equal to final kinetic energy minus initial kinetic energy. Correct? We subtract the value of final kinetic energy and initial kinetic energy. So we are getting it as 2.25 minus 6.25. So 2.25 minus 6.25 coming out to be how much? What is the answer? You are getting it as, just solve it and see, minus 4 joule. Okay. So minus sign indicates that the kinetic energy decreases. So the decrease in kinetic energy is 4 joule. Clear? Steps are clear. So you calculate the initial kinetic energy and final kinetic energy and subtract the value of initial kinetic energy from final kinetic energy, and you will get the difference in kinetic energy. Clear? Okay. Now let's solve question number 16. A cannonball of mass 500 gram is fired with a speed of 15 meter per second. Find the kinetic energy and its momentum. It's a very basic and direct question. The mass of the ball is given. Mass of the ball is given as 500 gram. So convert into kilogram. 0. Dividing by 1000, we get it as 0.5 kilogram. The speed is given 15 meter per second. This is the speed of the cannonball. First you have to calculate the kinetic energy. K is equal to half mv square. It's a direct problem. All the values are given there. Just place the value. 1 by 2 into 0.5 into v square. 15 into 15. Don't forget to square the velocity. So we are getting it as 56.25 joule. All of you solve it and you will get the value as value of kinetic energy of the ball, 56.25 joule. So that's the first part of the question. The second part, you have to calculate the momentum of the ball. So the momentum is given as P is equal to product of mass and velocity. All of you know the formula of the momentum. Momentum is nothing but it's the product of mass and velocity. Mass is given there, 0.5 kilogram into velocity is also given 15 meter per second. So we are getting the value of momentum P is equal to, multiply and see, 7.5 kilogram meter per second. That's the unit of momentum, kilogram meter per second. So clear? So it's a direct and basic problem. If you know the formula, you can easily do it. Now moving on to question number 17. A body of mass 10 kilogram is moving with a velocity of 20 meter per second. If the mass of the body is doubled and its velocity is halved, find the initial kinetic energy and second the final kinetic energy. So try to understand the case here. Here initial mass of the body, initial mass m1, it is given as 10 kilogram. Alright, and the initial velocity v, take it as v1, it is given as 20 meter per second. Okay, now what happens? Read the question. If the mass of the body is doubled and velocity is halved, okay, final mass, take the final mass as m2, it is doubled. So 2 times 10, that is 20 kilogram, and velocity, and the final velocity you take it as v2, it is given as half of the initial velocity, that is 20 divided by 2, that is 10 meter per second. Okay, so this is the case. So we have to calculate the initial kinetic energy. Initial kinetic energy K1 is equal to half m1 v1 square. So that is equal to 1 by 2 into what is the initial mass? 10 into v1 square, that is 20 square. 20 into 20. Solve it. We are getting it as the initial kinetic energy K1 400 multiplied by 5, we are getting it as 2000 joule. That is the initial kinetic energy. Now the final kinetic energy, take the final value. Final kinetic energy K2 is equal to half m2 v2 square. Take all the final values here. Okay, so that's equal to 1 by 2 into final mass. Mass is doubled, so that is 20 into v2. Velocity is half, 10 into 10. So we are getting it as 10. So 10 multiplied 100, 100 multiplied by 10, that's we are getting it as 1000 joule. Clear? So we are getting the value of kinetic energy, initial kinetic energy and final kinetic energy as 2000 joule and 1000 joule respectively. So read the question, understand it, what all conditions are given there. According to the conditions, you just place the value. You can easily solve the numericals once you know the formula. So that's all for today. Thanks for watching.